All right, get ready, because today we're taking a deep dive into some pretty complex physics stuff.
Yeah, looks like we've got a lot to cover.
Time travel, relativity, quantum mechanics. There's even a poem in here.
Wow, quite the mix.
You even gave us excerpts from A Chrononaut's Odyssey.
Sounds intriguing. Weaving a narrative through all these complex topics.
Yeah, so our mission is to sort through it all, find the good stuff,
Absolutely.
and hopefully come out of this with a deeper understanding of it all.
Sounds great.
And, maybe have some fun along the way, too.
For sure.
Let's start with the different types of time travel mentioned in your sources.
Okay, good place to start.
So, we've got multiversal time travel, basically hopping to a different universe.
Right.
Then there's the classic event-altering time travel, the one that always gives me a headache with all those paradoxes.
Oh, the paradoxes, yeah.
Like, you go back in time and accidentally prevent your own birth. How do you even exist to go back in time in the first place?
Right, exactly. The classic grandfather paradox.
It's mind-boggling.
Definitely is complicated.
Makes you wonder if messing with the past is even possible.
Or if you just create a whole new timeline.
Exactly, a whole new timeline.
Fascinating stuff.
Your sources also mention wormhole time travel, using those theoretical tunnels in space-time to travel vast distances, even to different points in time.
Ah, yes, wormholes.
They come from Einstein's theory of general relativity, right?
Exactly.
Where massive objects can actually warp space-time
Yeah.
and create these, shortcuts.
Yeah, like tunnels through the cosmos.
So out of these three types of time travel, which one seems the most, plausible to you?
Well, I mean, none of these have actually been scientifically proven.
Right.
It's all theoretical thought experiments.
Right.
But multiversal and wormhole time travel, at least in theory, fit within our understanding of physics.
Oh, okay.
Event-altering time travel? Well, with all those paradoxes,
Yeah.
it suggests it might be inherently impossible. Who knows?
Yeah, it's like the universe has these safeguards in place to prevent us from messing everything up.
Right, maybe, or maybe not.
But even if we never achieve actual time travel, thinking about these ideas,
Yeah,
it can lead to some pretty incredible insights and technological advancements.
for sure. It pushes the boundaries of our understanding.
Absolutely. Now, let's move on to something that is real, scientifically proven. Time dilation.
Okay, time dilation.
It's one of those mind-bending concepts straight from Einstein's theory of relativity.
Yeah, it challenges our everyday perception of time.
Right, time as a constant, that steady tick-tock.
Exactly, but Einstein showed us that time is relative.
So, wait, time can actually flow at different rates.
That's right.
Depending on your motion and the gravitational field you're in.
Precisely.
So you're saying that time actually moves differently on, say, the surface of the sun compared to here on Earth?
Exactly. Your sources even mentioned that time on the sun's surface runs about, 66.979 seconds slower per year.
Wow, that's crazy. So theoretically, if I spent a year on the sun,
Yeah.
I'd come back to Earth a tiny bit younger than everyone else.
Theoretically, yes,
Mm.
but we're talking about a tiny difference.
Right, and I'd probably need a lot of sunscreen.
Definitely.
But on a cosmic scale, that's got to have some huge implications.
Absolutely. It affects everything from GPS satellites to the way stars evolve.
So just to be clear, time dilation is real.
Yes.
It's been proven,
proven.
and it completely changes how we understand time.
Completely.
It's not this fixed, unchanging thing we thought it was.
Right. It's dynamic, flexible, constantly changing.
Wow. Okay, my mind is already starting to bend a little here.
Just a little.
And speaking of mind bending, your sources also mentioned Alice rings, which sound like something straight out of science fiction.
Alice rings. Yeah.
Can you tell us a bit more about them?
Well, they're theoretical constructs that could potentially allow us to navigate space-time itself.
Like a cosmic shortcut.
Exactly. A tunnel that could transport you vast distances across space, maybe even through time.
That sounds almost too good to be true.
It does, doesn't it?
How would something like that even work?
Well, the details get pretty complex.
I bet.
But your sources suggest that Alice rings might be created by manipulating something called dark electrons.
Dark electrons, okay.
They're hypothetical particles that interact with dark matter.
Right, dark matter.
That mysterious stuff that makes up a huge chunk of the universe.
The stuff we can't even see.
Exactly. Invisible. But it's there.
So dark matter is like this invisible scaffolding holding the universe together.
That's a good way to think about it.
And dark electrons are some of the particles making up this scaffolding.
Right.
But how do we even access these dark electrons? They sound pretty elusive.
Well, your sources mention the ontological medium of space-time.
Ontological medium of what?
Space-time.
Okay, that sounds complicated.
Think of it as the fabric of reality itself.
The very essence of space and time.
Exactly.
Okay.
And some physicists believe that dark electrons are embedded within this ontological medium.
Okay.
So if we can figure out how to interact with it,
We could extract these dark electrons.
maybe, it's all theoretical, of course.
Right, of course, but we're talking about tapping into the very fabric of reality.
That's the idea.
It sounds so ambitious, almost like science fiction.
It does, but remember, what seems impossible today might be commonplace tomorrow.
You've got a point there.
Look at the history of science. We've come a long way.
That's true. So how would we even begin to interact with this ontological medium?
Well, your sources point to something called whale materials.
Wheel materials.
They have some incredible properties when it comes to light and electrons.
Okay.
And some physicists believe they hold the potential for manipulating dark electrons and maybe, just maybe, creating Alice rings.
Whale materials. So we're talking about manipulating the universe at a subatomic level.
Essentially, yeah.
Using these, would you call them exotic materials?
Whale materials, yeah, they're pretty unique.
It's incredibly speculative, right?
Of course, incredibly.
Oh, we haven't even proven dark matter or dark electrons exist yet.
Not definitively, no.
Let alone figured out how to manipulate them to create wormholes.
Right, it's a long shot.
But it's fascinating to think about the possibility of warping space-time.
It is. It captures the imagination.
Like something straight out of Star Trek.
Exactly.
And speaking of pushing the boundaries of what's possible, your sources also mentioned the potential of the solar wind.
Ah, yes, the solar wind.
This constant stream of charged particles from the sun.
It's like a cosmic wind, always blowing.
And you're suggesting we could actually use it for space travel.
That's the idea. Imagine giant solar sails catching the momentum of this wind.
Wow, so like a cosmic sailboat?
Exactly, riding the solar wind across the solar system.
Without needing any fuel. That's amazing.
That's the potential.
And your sources also mentioned something about converting the solar wind's energy into electricity, right?
Yes, the solar wind is packed with energy.
So we could use it to power spacecraft systems.
Precisely. Instead of relying on heavy, inefficient fuel.
That sounds revolutionary.
It could completely change how we explore space.
Opening up all sorts of possibilities.
I-
It really highlights how interconnected all these ideas are.
It's all connected.
Time dilation, space travel, manipulating space-time, harnessing energy from the stars.
And it's all governed by the laws of physics.
It's incredible how exploring one concept can lead to all these other fascinating ideas,
It's like peeling back the layers of an onion.
revealing deeper and deeper levels of complexity.
And Runder.
And speaking of peeling back layers, let's dig a bit deeper into the quantum implications of time dilation.
Quantum implications, okay.
One of your sources asked a really interesting question. If time is slower on the sun, do atoms spin slower there?
Ah, that's a great question. Gets to the heart of quantum mechanics.
Yeah. If gravity affects time, shouldn't it also affect matter at the atomic level?
It's a fascinating area of inquiry.
Makes sense to me. If time is moving slower, wouldn't atoms spin slower too?
It's logical to think so.
And what would that mean for our understanding of the universe?
Well, we know gravity affects atomic behavior.
But how does time dilation specifically affect things like atomic spin and energy levels?
That's still being explored, but it's a crucial question.
And your sources suggest that even tiny differences in atomic spin caused by time dilation could have huge consequences.
Absolutely, much bigger than, say, losing a fraction of a day over thousands of years.
We're talking about potentially changing how chemical reactions work, how light interacts with matter, even the properties of particles themselves.
Exactly. Even small shifts in time could have massive ripple effects.
It really shows how everything is connected.
It all comes back to Einstein's theory of relativity,
And the idea that time and space aren't separate, they're intertwined.
a dynamic four-dimensional fabric.
It's amazing to think that something as simple as time can be so complex and have such profound implications for our understanding of the universe.
It's one of the great mysteries of science.
The more we learn, the more fascinating it becomes.
It definitely keeps us on our toes.
All right, I think my brain needs a moment to process all of this.
It's a lot to take in.
We'll pick up where we left off in part 2 of our deep dive into your source material.
Looking forward to it.
We'll delve into some more personal aspects of your research, including that poem you mentioned.
Sounds great. Until then.
Stay tuned, folks. Things are about to get even more interesting. Welcome back. All right, so before the break, we were talking about Alice rings and how they could potentially let us navigate through space-time.
Yeah, those hypothetical constructs.
Can you remind us how they're supposed to work?
Well, the key might be in these things called dark electrons,
Right, dark electrons.
which, if you remember, are these theoretical particles that interact with dark matter.
dark matter, that invisible stuff.
Yeah, the mysterious stuff that makes up a huge part of the universe.
No, we can't actually see it?
Nope, not directly.
So dark matter is like this invisible scaffolding holding everything together.
That's a good way to put it.
And dark electrons are some of the particles making up the scaffolding.
Right.
But how do we even get to these dark electrons?
Good question.
They seem pretty hard to find.
Well, your sources talk about this concept called the ontological medium of space-time.
The what of space-time?
Ontological medium. It's a mouthful, I know.
It sounds pretty complicated.
It is, but think of it like the fabric of reality itself.
The very essence of space and time.
Exactly.
Okay, I think I'm following so far.
Good. So some physicists think that these dark electrons are, like, embedded in this ontological medium.
So if we can figure out how to interact with it.
We might be able to extract these dark electrons, yeah.
So we're talking about like reaching into the fabric of reality itself.
That's the basic idea.
It sounds incredibly ambitious, almost impossible.
It does, but who knows what the future holds, right?
True. What seems impossible today might be totally normal tomorrow.
Exactly. Just look at how far we've come in science already.
That's a good point, but how would we even interact with this ontological medium in the first place?
Well, your sources mention whale materials.
Whale materials, what are those?
They have these really unique properties when it comes to light and electrons.
Okay.
And some physicists think they could be the key to manipulating dark electrons.
And potentially creating Alice rings.
Maybe. It's all theoretical, of course.
Right, of course, but we're talking about manipulating the universe at a subatomic level.
Yeah, pretty much.
Using these, what did you call them, whale materials?
Yeah, whale materials. They're pretty special.
That's all very speculative, right?
Incredibly so.
We haven't even proven dark matter or dark electrons exist for sure.
No, not definitively.
Let alone figured out how to use them to create wormholes.
It's a long shot for sure.
But it's still a fascinating idea to think about, warping space-time like that.
Oh, absolutely. It's mind-blowing.
Something straight out of Star Trek.
Exactly.
This brings us to another interesting idea. What if space-time itself isn't just this empty stage for matter and energy,
Right. Not just a backdrop.
but an active player, like it has
Right.
its own structure and properties?
Yeah, and that we could potentially manipulate those properties.
Your sources talk about space-time being like an electromagnetic fabric?
Woven from the spinning atoms that make up, well, everything.
So instead of being empty, space-time is actually buzzing with energy at the subatomic level.
That's the idea.
And your sources even use the word harass, like we could harass this fabric.
To find new ways to move through space without needing traditional fuel or engines.
So like surfing on the very fabric of space-time.
Riding the waves of energy that permeate the universe.
It sounds both poetic and scientifically intriguing.
It is, isn't it?
Makes you wonder if there are all these hidden dimensions or forces at play that we're just starting to understand.
Exactly. And maybe by studying these far-out ideas, we'll uncover even more.
Speaking of uncovering things, remember that mind-bending idea about observing the past from the center of the galaxy?
Oh, yeah, that one.
The idea that because of extreme time dilation near a black hole, you could see thousands of years of Earth's history in an instant.
Like a fast-forward button for the history of Earth.
It sounds like something out of a movie. Could actually be possible, though.
Well, theoretically, but it would require some insane technological advancements.
Just getting to the center of the galaxy would be a huge challenge.
A massive challenge.
And then figuring out how to capture and transmit that distorted view of time back to Earth.
We're talking about manipulating holograms, transmitting data across vast distances, maybe even manipulating space-time itself.
That's incredibly complex.
Beyond anything we've ever attempted.
But even if it's not possible right now, it shows the power of time dilation.
And how it can change our perception of time itself.
It's amazing to think that time, which seems so linear and unchanging to us,
Can actually be so fluid and malleable.
it really challenges our whole idea of reality.
It does. It highlights how important observation is.
What we observe and how we observe it shapes our understanding of everything.
It's like that saying, you don't see the world as it is, you see it as you are.
Exactly. Our perception colors everything.
And this idea of observation shaping reality ties in perfectly with that poem you shared.
It does, doesn't it? It's not just a creative piece. It seems to really engage with these ideas of time, space, and observation.
It does. I'm really looking forward to discussing it.
Me too. Let's dive into the poetic side of this cosmic journey. You know, after going through all that mind-bending science stuff,
I know, right?
it's amazing how a poem can really capture those feelings.
It's true. Your poem really blends science, mythology, personal reflection.
Yeah, in a way that connects with all those ideas we've been talking about.
Absolutely.
Okay, so There's this one line that really stuck with me.
Okay, which one?
Saturn's jail escaped, and by its rings I stride, beyond the Sea Queen's consort, Hades demoted, stands aside.
Hmm. Yeah, powerful imagery.
Like breaking free, going beyond limitations.
It does. It speaks to that human desire,
To push further, explore the unknown.
the cosmos, the mysteries of time and space,
Exactly, like the poem's encouraging us to just let go of our old ideas.
and embrace the unknown.
Venture out into those uncharted territories.
I like that. And the imagery is so vivid.
Saturn, right. Usually associated with limits, restrictions.
And here it is, left behind.
The journey goes beyond even those powerful figures, the Sea Queen's consort, Hades.
It's like the poem saying true knowledge needs us to step outside those old systems.
Forge our own path, right? Through the cosmos.
That's a great interpretation.
And then there's the ending. If you can hear, you can see. Now in Seven Sister Sentience, Horus is free.
What do you make of that?
Well, the Seven Sisters, they're often linked with wisdom, insight, right?
A higher level of awareness.
A new way of seeing things.
And Horus, the Egyptian god of light, vision.
Being freed, like understanding has been liberated.
A new way to see the universe.
Like the poem saying, true knowledge isn't just observing.
It's deeper, more intuitive.
A merging of science and the spiritual, maybe.
That's a beautiful way to put it. The interconnectedness of everything.
We're not just watching the universe, we're part of it.
Participating in its story.
It reminds us that discovery is also about inner transformation.
Absolutely, not just the outer exploration.
So, wow, we've covered a lot today.
Time travel, relativity, quantum mechanics, poetry.
What are some key takeaways for our listener?
What should they be thinking about after all this?
Well, I think the biggest one is time is way more complex than we usually think.
It's not just a straight line, ticking away.
Right, it's fluid, dynamic, affected by so many things.
Gravity, motion, maybe even our own perception.
And that changes how we understand the universe.
Absolutely, it opens up so many possibilities.
Like using solar wind for space travel, those Alice rings.
Manipulating space-time itself,
And
even.
even if some of those are just theories.
They push us to think differently, to imagine what might be possible.
It shows us there's always more to learn. The journey never really ends.
And who knows, maybe someday we'll figure out time travel for real.
Until then, we keep exploring, keep asking questions, keep looking up at the stars.
Whale said, it's been an amazing journey exploring all this with you.
Absolutely. And to our listener, think about this. If you could time travel, where would you go? What mysteries would you solve? Keep exploring, keep questioning, and we'll see you next time.